Hello. Uh, yes, we welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, today we are looking at this case. It says that a train accelerates steadily from 4 meters per second at 20 meters per second in 150 seconds. Okay. And the question says that calculate its acceleration. Yes, how do you go about this? Here you have to be reminded that acceleration is given by a change in velocity, which is final velocity minus initial velocity over change in time. So when you check for this, what do we have? You have A, which we don't know, is what we are calculating. We have the final velocity, which is 20 meters per second. And you have the initial velocity, which is 4 meters per second. And you have change in time, which is 150 seconds. Okay, with this information, what do? We substitute. Okay, we are going to have A, which is equal to 20 minus 4 over 150. Yeah, this one will give us 16 over 150, which is equal to, giving us this, which is 0.11 meters per second. Yeah, so we have that. This is 0.11 meters per second squared. Oh, yes. Yeah, then we go to question number 2. Distance it covers in this period of time. So in this case, we are calculating displacement. We don't know it, but we know initial velocity, which is 4 meters per second. We know final velocity, which is 20 meters per second. But we also know acceleration, which is 0.11 meters per second squared. Yes, with this information, what do? Yeah, we must not forget that we also know time, which is 150 seconds. So we have a lot of information here. So which probably we can have 2 equations which you can use. Let us start with one. Suppose we use this one. Displacement is equal to final velocity plus initial velocity over 2 into delta t. Yeah, if you decide to use this, what do? We have to substitute. And what is the final velocity? It is 20. And what is the initial velocity? It is 4. This one over 2. And you multiply with time, which is 150. Okay. Yeah, what do we get? Yeah, so giving us this. Yeah, alternatively, we can look for another equation. Let us look for another one. We can use VF squared, which is the second equation, is equal to VI squared plus 2A delta X. Yeah, that one can work because we have delta X. Even we can use delta X, which is equal to VI delta T plus half A delta T squared. Still we can use that. So technically, you pick the equation whose data you are having. Yeah, then you come to number 3. Number 3 says calculate its average velocity. We must not forget that our distance we've got here is 1,800 meters. Yeah. So in this case, we have two approaches. The first one, we looked at it before. It says that average velocity is equal to total displacement over total change in time. Okay, so if we are calculating for average displacement here, what information do we have? The information we have total displacement is already covered. It is 1,800 meters, and we know total time, which is 150, giving us 12 meters per second. Okay, another alternative, we can use this. Average velocity is equal to V final plus V initial over 2. Yes, the way we used to do averages in grade 8. Yeah, you add, if you have two entities, you add them and divide by the number of entities. So here we have two velocities, the final and initial. So you add them and divide by 2. So what is the final velocity? It is 20. And our initial velocity is 4. So divide by 2. So here what are we going to get? We are going to get 24 divided by 2, giving us 12 meters per second. Yeah, then we come to this question. It says that draw acceleration versus time graph for the train. Yes, how does this graph appear? Yeah, so here we have the axis. On y you have the acceleration, and on x you have the time. And we are representing uniform acceleration. Why? Because they say a train accelerates steadily. So every time you are representing uniform acceleration, it is a straight line, a horizontal straight line like this. That's the graph. And what do we have here? The figure we have here is the acceleration we calculated, which is here. So it's going to be 0.11 meters per second squared, With that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yeah, we urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye bye.